Now, this is the first part of our new topic, which is very similar to what we did in our previous topic under gravitational field. But this one is electric field. The only difference is that in the case of gravitational field, where we are dealing with masses, so here we are going to be dealing with what? Charges. So, and we are going to use Coulomb's law to explain the topic. Now, when we are talking about electric field, we have two charges there. Once you are having different charges, it can be positive or negative. But in the case of a gravitational field, there's nothing like that. That's why under gravitational field, what we have is solely attractive force. But here now that we are having two different charges, it can be positive and positive, or negative and negative, or positive and negative. In that case, it is possible to have attractive force or repulsive force, depend on the kind of charges. For instance, if you have the force between positive and positive, it will be what? Repulsive force. Don't forget the fundamental law of electrostatic that says like charges repel each other, unlike charges attract each other. This is like charges, so they are going to repel each other. So the force we are going to calculate here will be repulsive force. The same formula. Then, what if you now have positive and negative? So in this case, we are going to have attractive force. Or if you have negative and negative, it's repulsive force. But if you have positive and negative, it's attractive force. Now, how are we now going to know the quantity of that particular force? Like we did under gravitational field. Very simple. Depend on two factors as well. Like we did under gravitational field. Don't forget, electric field is a region under the influence of electricity. Now, if you now have two charges, we have two charges, it depends on how big the quantity of charge in each or both bodies. So as you are increasing the charges, the quantity of force will be increasing. As you are now increasing the distance between them, what will happen? The force between them will be what? Reducing. Now, that will now lead us to Coulomb's law itself that says the force between two charged bodies vary directly with the product of the what? Of the two charges, and inversely with the square of separation distance between them. That is, if you have the charge like this, as you are increasing it, like we did under gravitational field, increase one or both of them, the force of attraction will increase, or the force of repulsion, depend on the kind of the charges. Or if you now have the same charges and you are increasing the distance, as you are separating it them more, so the force will be reducing. Now, let's go and derive the formula like we did under gravitational field. Very simple, similar thing. But in the case of the gravitational field, we use masses. Here, we are going to be using what? Charges. Now, it can have what? Positive and positive, or negative and negative, or positive and negative. But what we know is that what will happen to them is that the force will increase when you increase either charge or both charges, and it will reduce when you increase their separation distance. Therefore, we have force vary directly with what? Product of the charges, Q1, Q2. The second part of the statement of the law, that is F vary inversely as what? R squared. Then you combine this and this together. It will give you F vary directly as what? Q1, Q2 over what? R squared. Then, in the case of gravitational field, our constant is gravitational constant G. But here, our constant is what? Electric constant K. Therefore, F is equal to K, Q1, Q2 over R squared. Where this K is equal to 1 over 4 pi epsilon. Where this epsilon means the permittivity of the medium. So the whole of this one can be 9 times 10 raised to power 9. Then, like we did under gravitational field, so you can make the K the subject of formula to know what will be the unit of K. Now, the next topic, we are going to base it on electric field intensity and electric field potential.